got a BIM manual there. I'm going to leave it at the faculty of the library. I'll leave it here as well. It would be, I think, beneficial for people to go through it. It's not an easy read, I can tell you that, but it would be great. So traditionally, so one of the basic benefits of BIM for a contractor is absolutely coordination between the different trades, mechanical, electrical, plumbing, you name it, architectural features. And in the past, how many of you are familiar? You guys are young. But so you don't remember the light table. We had one actually at the faculty here before. It's a light table. We used to trace over that, right? But in construction out in the field, we use it for a different purpose. We use it to coordinate. So you put the two-dimensional drawings, the electrical drawing, you put the mechanical drawing, and you see how the systems are working together. But it was manually done, and it had a lot of flaws. We talked earlier about looking at waste and eliminating waste from a lean practice. This was a wasteful process for us to go through. And some of the results of this process were disastrous, and the reason being, designers specify in single line drawings. And so if you look at an electrical pipe or electric distribution, it's only a single line drawing. Same thing for piping, same thing for HVAC. It's only a single line, and you're not able to decipher elevations. You're not able to decipher the interaction between the two systems. What ends up happening is something like this, where you've got a sprinkler system going through a duct. Guaranteed, sometimes you may or have to, so I'm not saying this is completely wrong, because sometimes you have to do this, there's no space, but you have to engineer it to do it. But this one was done by mistake. So this is a classic mistake when systems are not coordinated properly. So normally you see, so you saw the first image where people, spend a lot of time coordinating what's above the ceiling. We spend a lot of time also coordinating what's below the floor, all the utilities, and I also stripped out everything that's above ceiling just to show the degree of detail. So even the hangers for the ducts and the raceways for the electrical, conduits, we model everything and coordinate basically everything. And this is the end result, essentially. And so these hangers are coordinated through the model and are installed precisely through the model. And obviously some of these pipes, underground pipes as well. What BIM helps us also to achieve, not just coordination between utilities, but even conducting some constructability reviews. Something as simple as a handicap or an ADA grab bar that conflicts with a riser, a drainage riser. You don't see that on the drawing. All right, Javier, what was it? ADA. ADA is the American Disability Act. Okay, and so it's the governing act that governs all of the different requirements for ADA. And so, by the way, for those of you who came in late, Abir is my kind of police there for acronyms. So anything that's 3-letter words, she's helping me make sure that I explain what they are, because we love our acronyms in the US. And so even the architect, the designer, these are things that they don't see, essentially. And so what our recommendation for them to be is that this riser needs to move so that there is no conflict with the grab bar. Otherwise, if it was installed, we would have an issue, right? That pipe would have been punctured. And we would have a big mess in this is a hospital. And so, again, a construction project is unique by its nature. You don't get to practice, you don't get to, so if we had built this wrong, it would have been a lot of dollars. And I'm not sure about here, I think I remember clearly, but in the US, we would have been held responsible for something like this, because the design intent, a general contractor is held responsible for the design intent. The architect drew this at the right height. The plumbing engineer drew this where it needs to be. It's the general contractor's responsibility to coordinate between the two. Like I said, we model up to 2 inches, quarter of an inch in diameter. So a quarter of an inch in diameter, that's probably like let's say a half centimeter. And so we even model our rebar, footings, beams, you name it, to move them in places where the structural integrity is still, achieved. And so when you think about BIM, think as the right level of detail. So those are the key elements, is that how much do I model, and what level of detail do I go into? We do a lot of virtual mock-ups, and I'll show you later a video that actually shows how we walk the owners. This is an operation theater or operation room in a hospital. Nurses, doctors have a problem with 2-dimensional drawings. They cannot visualize where everything is, including even like trash cans and where is my glove box, and they have a problem visualizing that. When you walk them through a 3-dimensional model, and we physically, one of the videos is going to show, obviously the sound is going to have a problem, but I'll still run the video so that at least you can see how we use, we don't have a cave ourselves, but we do. Are you guys familiar with Oculus? Facebook Oculus, it's a goggles that you wear, and then you're able to walk through, virtual worlds. And so that's how we're able to walk them through. And so again, our contracts require us to build physical mock-ups. They cost money, and they're time-consuming as well. They cost less because they cost obviously bytes in terms of IT bytes or information technology bytes, right? But they help them actually visualize what is it going to look like. It's not reality, though it's not like a 3D Max model, but it's a physical model that have information. And if they start asking us, what's the model of this table or that monitor or the operating light, the overhead light, you can just walk them through right to it, you click on it, it gives them all the information they need about the models. Like I said, we model up to up to a quarter of an inch, and so even like the support for the light fixtures, the support for the booms, the light booms, for the operating theater, for any type of equipment, all the miscellaneous steel we model. These are metal studs for drywall. This is the backing for anything like cabinets and anything that gets handled on the wall gets modeled as well. And we are able to make those decisions. The one you saw earlier with the what is it called, the sprinkler system, and that was a mistake. This is by design. Is that when we can't move things, then we need to penetrate this beam or joist, but we do make sure that the structural engineer gives their blessing, right? And then we make sure it's built based on what has been approved. Like I said, we self-perform concrete, so concrete is a big part of our business, and sometimes we get into a lot of complicated formwork or shutters. And so we model, so these are prefabricated, even though it's wood. It's prefabricated, so we model it first, we send it to the shop, and then we're able to prefabricate, the formwork. This is an interesting, so I'm sure a lot of you have seen the videos coming out of China, building buildings in, a few days or a few months. And that puts a lot of pressure on us in the US. We can't compete with China. And so one of the outcomes of the utilization of it is that we can get very precise on the dimensions of the elements. And so this is, again, it's a double bathroom in a hospital, basically two patient rooms adjoining. We're able to prefabricate actually these bathrooms in Phoenix and ship them to the Bay Area in San Francisco. This is this is a hospital in California. And the reason we built them in Phoenix or Arizona is a non-union, state. California unions are very strict, and so we can't prefabricate this in a shop and bring a lot of different unions, the drywall unions, the electricians, the plumbers. Their union won't allow them to come into one place off-site to build something and then move it into. It was more economical for us to build it in Arizona. I'll run the video anyways. I'm sure we'll have an issue with the sound, but hopefully it comes out okay. I would say the fifth level of BIM, and I'll talk about the different levels of BIM that we go through. So not every general contractor in the US uses or leverages BIM to its fifth level. Some may decide just to use it for visualization, which is just I want to produce a three-dimensional representation of what the building looks like. That would be the first just to produce a three-dimensional object to show to owners or to subcontractors. Again, these are head walls that go into hospitals where you've got all of the medical gases and all the electrical and even some of the imaging equipment that gets attached into the walls. Today we're able to prefabricate off-site and move back into because again, without BIM we could have done this. I'm not going to say or advocate that without BIM we wouldn't have been able to do it. We would have been able to do it, but it would have been challenging for us to accomplish or do. BIM brings the predictability, brings the precision to where we can produce and prefabricate components of a building and then ship them and know exactly they're going to fit, and they're going to fit right. From a supply chain, anybody familiar with Tekla? Tekla is a structural, it's a kind of a structural, software we use for, not to design, but to make representations. But we've been able to use it, for a different purpose. Like I said, we do self-perform our own, we install our own door frames and hardware. And so from a supply chain, we're able to leverage Tekla to use and track where our doors and frames are And so from the manufacturer to the time they get delivered to the job site, through the inspection process until they get installed, and you can look at a BIM model and find out which doors are installed, which doors are defective, which doors are not installed, and then completely, get right information or real-time information at your fingertips. We've got actually right now, a test happening with humans. We're tracking our laborers. We're tracking not just our laborers, but even the subcontractors' labors. This is one, call it pilot, call it proof of concept. And so we track our laborers have badges. They scan their badges. It's a live RFID badge. And so we can see where they are on the job. You can open actually the model and see where people are moving. And so for safety, these are large projects, very complex projects. You don't want somebody going into a place, you have an evacuation situation, and somebody is in the building and is not completely evacuated. And so we're hoping that we can even track productivity through tracking people. Again, this is just an experiment. It's not, we published a white paper actually, if you go on the internet and you search it, you're going to find it. But I think it's a very insightful experiment that we've done, and I hope that it proves beneficial. So our BIM process today is a lean, integrated process, bringing the right people at the right time in the right place, and that is key. To be able, so can I implement BIM without any lean practices and any integration of teams? Absolutely you can. Can I implement integrated project delivery without BIM and without lean? Yes, you can. Can I implement lean practices without the other two? Yes, you can. However, to reap the benefit, we think, and we've proven by delivering a lot of projects, by bringing the right people, involving our engineers and consultants, subcontractors, including the owners, and the DPR teams, is that we're able to produce the right amount of information and deliver it at the right time when it's needed. We use a lot of these, smart boards. Familiar with smart boards? So we leverage smart boards to really review and coordinate, during those sessions. So the entire team's huddle around the smart board. The smart board allows us to really manipulate and move things live. And with the presence of the engineers and the consultants, some of the decisions can be made right there without having to go back to the office, do recalculations. Obviously, some changes may require some calculations to be able to, to get done. But for the most part, we're able to coordinate live at the job site, eliminate a lot of the coordination issues. And then again, just can I do it without a smart board? Absolutely. You can just project on a white wall. You don't need a smart board for this. This is some of our latest technologies. Anybody familiar with laser scanning? Okay. So laser scanning is taking BIM to the next level, or capturing what has been installed, or as-building what's existed. And so the example I would give here, if I ask at the university, I ask the building and construction unit, and I say, do you have drawings for the library? They may, right? But most chances are they don't. It's been a historic building for I don't know how many years. Most likely they don't. So how can they actually produce drawings for an existing building? What we do is we bring in our laser scanners, we scan the building entirely, and then we're able to produce a model then that you can actually produce two-dimensional drawings, sections. So this is an electric room. Maybe it's not the best example. This is an electric room. That's the photo. It's far. You can't see it. We scan the entire room. That's a point cloud. Basically, and I'll show you the next. Maybe the next one is better. So this is an interior. This is a Leica scanner. And what it does, it actually just shoots laser, it rotates. Inside there's an element that rotates, and it shoots laser on the entire space. While it's doing this, obviously it shoots the laser, it comes back, and it's actually making a model with every point that it's coming back. And so that's the result of the model that comes out of the laser scanner. And then we take it and produce out of that, we basically put a skin on the points because there's a lot of dots, or a lot of points in that model. If I magnify this, you're going to see just a lot of dots. Then we put a skin on top of it. Then it becomes an element or an object. So that becomes a column, that becomes a dot, and that becomes a wall. And now we're able to produce documentation of an existing building that does not have documentation. We have a lot of either historic buildings or facilities that we go in to renovate, right? Or completely demolish the interior and renovate. And we don't have any as-built to go by. So what we do, we bring in our laser scanners, we scan the building, produce a model, then produce two-dimensional drawings or three-dimensional drawings. And these are intelligent models, and so you can see here that panel there, that electric panel. If you click on it, it gives you the entire data about what the panel contains. This is not just for interiors; it's actually also for exteriors. And so that's a building that we were able to shoot, laser scan it. You can do this, by the way, using photographs as well. There are some applications that allow you to take photographs, and then you bring those photographs, stitch them together, and produce a model similar to this. I think Autodesk has it's in infancy. It's not yet a fully fledged application, I would say. It's called PhotoFly, that allows you to produce a model similar to this. See these dots? That's how a point cloud model looks like. But then you start putting the skin on it, it starts getting a little bit more solidified, it starts to get a little bit more, the object starts to take shape. And then you can take this and take it to Revit, and now you've got, a completely, fully fledged model that you can then produce, documents from. So does that make sense? So that's what a point cloud is and how it's produced to get a model in place. We use also laser scanning for quality control or for quality check. So even though sometimes we coordinate these underground pipes, however, after they're in place, they may move because somebody may kick them, right? You've got other equipment, forklifts, whatever it may be. They may move actually from their place, and then when you do the laser scanning, so this is the laser scan, this is the fully fledged model. You can see some of them have moved just slightly from where they need to be compared to where the model is. The only problem we find with this, it takes time. And so by the time we install the pipes, we need to pour concrete. The information doesn't come back until 24 hours later. And it does take time. So what we're doing right now, we're actually venturing into drones. How many have used drones or have seen the drone in action when it comes to construction? So I'll run a video here as well. It doesn't have any sound. I don't think this one has any sound. So this is the flight path that the drone took. And the drone basically has a GoPro camera attached to it. And then we're able to take that, those shots, stitch them together, and produce a model. So this is not a photo. This is a true model that I can even. So this is some of the things that we're currently piloting and working with. This is not on every job site. This is not on every project. I think currently we've got about 10 projects that have drones flying to produce as-built and to produce or capture the reality of what has been installed. And I think what we're able or hoping to be able to glean is that we can compare actuals to what has been designed. So the cut and fill, more specifically on the civil side, right, is that you've got to cut and you've got to fill and you have grades that you need to maintain. And these types of models will allow us to be able to quantify what have we cut, what have we filled. And so again, this is emerging, technology. This is not prevalent. This is not on every job site. But again, it helped us capture what has been installed and compare it to. And we were honestly spending a lot of money using aerial photographs, and either by a helicopter or a satellite, aerial photographs, just to look at progress or measure progress on projects. With drones, these drones cost about $400 to $600, about $2,000 to $2,000 to $4,000, and attach the camera to them, and then fly them, and they don't require a lot of training. So what's next for us? We are actually heavily investing currently on augmented reality. So we were talking earlier about virtual reality, right? So things that you build on a computer, you look at them on a computer, or you look at them on a, what is it called? Any type of device like goggles or a cape even. What we're venturing into is augmented reality, is that you're looking at things through a different lens. You're looking at something that has been completely built, yet at the same time, you're superimposing what else that needs to go. So these are patient groups in a hospital. And you can see through this camera right here, we're able to look at this wall and see actually this wall has different components that go on the wall itself. Right? So that helps us deliver the information to the foreman level, to the laborers level, who are actually building the buildings. At the same time, we're able to deliver this information to our owners, to the end users. I guarantee you, even this space exists, right? A nurse or even a doctor walking inside this room, they will still be disoriented. They won't know where the bed goes versus where the TV goes for the patient. But by bringing the virtual components to them, by having them look on the computer screen, they will be able to visually